Hello, everyone. Thank you for joining us for our next session, GitHub Copilot Token Optimization. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, we'll turn it over to our speaker for today. Thanks for joining.
Hey, how's it going, everybody? I'm Todd Toller, and I am a cloud solution architect, or senior cloud solution architect with Microsoft. I'm in what we call the Tech Success Developer Productivity team. And so as part of that, we're here to help help you guys understand agent quality and token optimization. So welcome. We're excited to have you here. So the motivation of this course is of course kind of the GitHub switch from premium requests to usage-based billing. So it's a huge change, and so it's raised a lot of questions about token consumption. So customers are often asking us, how do we improve our token spend? How do we understand our how optimized our tokens are? What our general token economics are? We hope to answer some of those questions here today and get you a nice foundation to start with. So we're afraid we don't want you to necessarily focus completely on cost, because there's a lot of different pieces, and focusing on cost can kind of diminish the value you get out of Copilot. So the better question to ask is, how can we make the most out of the tokens that we spend? And with that, you'll start to see how to really combine a lot of these pieces together. With that, it actually comes with token optimizations, as we'll learn. So we'll get into that in just a moment here. So we'll get into slide 2. So there's 3 parts to this presentation. There's part 1, which is why agent quality is the better focus. So we'll explore why optimizing for quality beats optimizing for cost alone, and how quality improvements can naturally reduce token spend. Part 2 is going to be a little bit of a foundation. So we'll cover the fundamentals of large language models, agents, and context windows. So that foundation will help you gain a deep understanding about optimizations and quality. But it'll also help you evaluate the hundreds of token optimization tips circulating online and form your own judgment about what works. There's a lot of information out there. Not all of it's completely accurate. So the more we can guide you along that path, the better off we hope you're going to be. So part 3 of that is quality and token controls and practical optimization tips. So we'll dive into some practical controls that you can employ, from model choice to prompts to agent configs, with some actionable optimization tips here. So the goal here is for you to be better with less. It's kind of the mantra of the post-COVID era, right? Do more with less. I always say that backwards. So it's the right way. I said it the right way this time. So anyways, let's start with why agent quality is the better focus. So to understand this, let's look at how the industry is operating today. Each of us is how each of us is probably acting. We're using agents in what I'd call somewhat of a gambling system. And so the NASA, we have this NASA Artemis analogy that if rockets were cheap, NASA could just send 20 rockets roughly in the direction of the moon. If one of them landed, perfect. If none of them landed, you just send off the next 20. And that maps precisely to how agents are often used and have been used. So you give only a little bit of context, you write a prompt, but don't put too much effort into it, and then you send the agent on its way. If it comes back with a good result, great. If it doesn't, you just send off the next agent, shoot them at the moon, however you want to look at it. The problem with that gambling approach is that it's no longer sustainable. It never really was, and it's part of what we're seeing. Now that code has become cheap, you have to think about the way that tokens are spent. And so it was sustainable when you only had 2, 3, or 4 agents a day. it's no longer sustainable in the direction we're moving, where dozens, if not hundreds of agents get dispatched by every single developer every day. And that number is just increasing exponentially as we move on. So those agent sessions are becoming longer and longer and longer, and more tokens and more tokens. And so, it's not sustainable from a financial point of view for us, for GitHub and Microsoft, because we used to bear that cost. When if a PRU was used and it was a couple hundred tokens, we generally probably made some money on it. If it was tens of thousands of tokens, we generally lost a fair amount of money on it. Compute is not cheap in this day and age. So, we used to bear that cost. And so now we're switching to a usage-based model. It's no longer sustainable for you as the customer either. So it's time for a change to kind of understand how to go forward with it. So if you look at this purely from a cost angle, the question becomes, how can we make the fuel cheaper? And so that's really just asking, how can we continue to gamble? And that isn't the right thing to do here. That's not what we want to see. So I also want you to think about what we want, what it is. I also don't think that it's actually what you want to do. And so instead, we should work on decreasing the number of rockets that we send out. So because more of them will actually hit the target, the more, in other words, we need to increase the value of each and every agent and increase the quality of the agents that we send before we send them out, so that none of them, so that before we send them out, so they all reach the target. So we need fewer agents. Fewer agents automatically means fewer tokens spent, and we need them to do it on a, which needs to start working on a better return on investment for our agents. It's a big shift in the way we think about it. And so increasing the value of an agent means we have to increase its quality. And so, you have to make the rocket land. And you think about, all the different, NASA and I guess SpaceX and some of the others, how they do it. They're not off firing things that they know are gonna crash or explode on the way out and hope that if you get, they're very refined. They give it a lot of context to get exactly where it needs to go, and they know at a pretty high percentage that it's going to make it. And so, optimizing cost, because when optimizing cost when the value is zero is useless work, as we can clearly see when looking at the ROI formula here. So this is the standard ROI formula applied to agentic development. One caveat to it is that you can't really calculate it cleanly. How do you quantify the value of an agent output? A lot of companies struggle with this, and honestly, we don't have a perfect recommendation either. But just because you can't calculate the formula doesn't mean it isn't true. And so it's still useful as guidance, and that helps us. That kind of helps us directionally. But there's another dynamic at play that makes this argument even stronger. Often increasing the value of an agent is achieved by actually decreasing the amount of tokens, by increasing the amount of tokens. What we see many developers do is stuff that is irrelevant and put way too much text into context windows, and they let conversations compound with that useless information that they pay for at every single turn. So reducing that context is a huge lever for both for better quality and less token costs. You're going to get better quality responses quicker for cheaper. And so this is not the only reason that we want it. That quality is going to play a huge role with ROI. So there's a third reason that why focusing on quality is more important: the compounding error problem. And so large language models are non-deterministic. They have an error margin and will never be 100% accurate. It's really kind of the model of the way it is. In multi-step agentic workflow, that creates compounding errors. So here's some of the math. At 99% accuracy per step, which is optimistic, admittedly, 50 steps reduces your overall accuracy to just 61%. You can see that on the chart here. Drop to 95% per step still sounds pretty solid, but it's you end up at 8% accuracy over 50 steps. And that's 8% accurate is nowhere. It's not what I would consider real successful. So this doesn't mean that every agent's going to fail, but it means every quality improvement dramatically increases your chances of success. And so we want to consider the cost. Every agent every agent miss wastes those tokens and requiring bug fixes, reviews, and additional agent runs. So you might even have incidents caused by low quality agent output. So in classical software development, we address this kind of problem with the shift left movement. So shift left quality, testing, security, all of that becomes even more true in agentic systems. So to sum things up, instead of counting tokens, we want to make every token count. So yeah, reduce the token size, but not driven by cost. You want to drive that by quality. So you want to send few rockets with high accuracy, which will automatically optimize the fuel. And so it's a different way of looking at it, but it's a way that you're going to get better success. So to increase the quality of agents, we first have to understand how all of this works. The LLMs, the agents, the context window, and how it all kind of ties together. So a quick kind of high-level refresher here. I'm sure you all probably know this at some level, LLMs and everything has been out there, but an LLM is a text-in, text-out machine. Under the hood, it's really just a word probability machine that, given the input and the training data, it predicts the most probable next word. And then the next, until a sentence is formed. It just continues to do that until that sentence is formed. In coding, it uses the same mechanics, just predicting the next instruction or statement instead of prose. So of course, models got better and better over the past few years, and a lot of bells and whistles got added for more compute, higher accuracy, biases towards software development, etc. But the underlying principle and capabilities are still very much just this. So, when mapped to response quality, the core principle is context bounds. So provide as little context as possible, but as much as required. So that's a huge, you got to kind of find, it's, kind of the Goldilocks effect, or the Goldilocks context. The Goldilocks context. So too much context would be irrelevant information, biases the model towards incorrect answers, and the LLMs can't distinguish relevant from irrelevant data. So it considers everything when it's calculating those possibilities. Too little context, it'll miss critical information. It's the biases, that can help bias the models from correct knowledge. And so, worse, the model may hallucinate to fill some gaps. So there's no error message indicating it lacked information. It's just going to kind of fill in and could potentially lead you an incorrect way. So the math makes no distinction between hallucination and fact. So this is why context engineering is the fundamental skill for working with agents. Okay, so with agents, the previous rule matters even more. So because it's no longer a single back and forth, the agent talks to the LLM on your behalf. It's dozens of times. Before it comes back to you, it's talking constantly, getting all the information. And all of that costs, a little bit of token, has a little bit of token cost tied to it. So an agent is just an app. It's some code. There are many harnesses offered by GitHub. So you got VS Code, Chat, where it all started in the IDE. You got Copilot CLI, which is a great tool. Copilot Cloud Agent, which is the GitHub.com page, and you have third-party harnesses like Claude Code and OpenAI's Codex. So the LLM is just the model. GPT, Claude, Gemini. There's others. We have some Microsoft models even. And so now, what we need to understand here is that the way an agent interacts with it is not magic. It's still just text. So, but critically, that's stateless text. And so it doesn't have the state that you would typically see. So an LLM does not store conversations. Having a conversation actually means resending the entirety of those inputs and outputs in order every single turn. So tokens and context compound on each other as you continue that conversation. So as you can see, the harness in and of itself already has a large role in agent quality, but you still have ways to influence it. So your levers to influence the agent are your prompt, the files in your project, the agent configs such as instructions, skills, and MCPs, and and so on. So there's a lot of ways that you can steer it and kind of give it that path, the path that you want it to follow. So understanding token consumption is a big piece. So let's look under the hood at context windows. On every loop, the agent sends the entire conversation to the LLM again. And so Loop one would be the system prompt and the tools, the description of available functions like read file, write file, and then your prompt, plus some file references. Those all equal input tokens. The response back is what the LLM responds. Those are output tokens, which are a little bit cheaper than input, or a little bit more expensive than input tokens. Loop 2 and beyond includes all of loop 1, plus the previous responses, and then new input, and it equals more tokens. So you can see it's just adding, it's a compounding context window. And so 1 token equals basically 3/4 of an English word. Think 1 token equals 1 word as a mental model. And so context limits vary. Smaller models can handle 50 to 200,000 tokens, while larger models like Claude Opus or GPT-5.5 can handle 1 million tokens. 1 million tokens equals the Lord of the Rings trilogy and The Hobbit, for some context based on that 1 word. 1 word equals, or 1 token equals 3/4 of an English word. So don't get caught up in the the tokenization details. It's not that it's not that critical as to what you want to do. You don't have to understand it at that level, but you don't have that much control over it anyways. But think of it at a higher level, like prompts, files, responses. Those all consume tokens, and they compound at each one of these loops. So you want to make sure that what you're using is as efficient as possible. So we'll get into this now. So we'll get into control, or before we get into controls, we need to understand 2 major problems with context windows. There's the kind of lost in the middle, number 1 section here. The model favors content at the beginning and end of the context window. It's not in the middle. And so this is usually fine, because the beginning is your instructions, goals, and plan. You want to prioritize that. The middle, or the end, is your current work stream. It's also important. But the middle is past work, and it's a little less relevant. The problem hits when you switch tasks mid-session. So you start with a bug fix, and then mid-conversation say, now let's implement a feature. As the window grows, the model may suddenly switch back to the bug fix because it biases the initial statement over recent ones. And so you want to use a new context window for each distinct task. And so you want to that's something that you want to keep in mind as you do it. You can use /clear in Copilot CLI and so on and so forth. Recency bias is accounts for about 50% of the tokens too. So above 50% capacity, the model starts favoring only the end of the conversation. And so it forgets your system instructions, your custom instructions, and original prompt, and the model drifts, doing things you don't understand based solely on the recent context. So as it gets further and further away, it can see less and less what you actually asked it to do. So don't let your token window grow beyond 60 to 70% unless it's absolutely necessary, right? So dividing and conquering tasks from the get-go is the best to counter this problem, followed by potentially compounding a conversation. So don't take this as something that will always happen. It's not, it's not the case. Bias doesn't mean the model will forget everything in the middle. We don't deal in absolutes, right? We're not Sith. There are scenarios where you'll need to go above 50% of the token window, 60, 70, 80, and even potentially get up to 100. That's all fine. Use it as you need to. It's just something to keep in mind as you start to optimize usage. The more you can keep these, keep it down, the more targeted your result is, the cheaper it's going to be overall. So hopefully this gives you a good foundational understanding of tokens, the context windows and large language models and agents, and the first ideas on how to optimize your usage. With this knowledge, let's now look at the practical guidance and things you can do starting today to improve the quality of your agents and your tokens. So before we dive in, one thing to understand, depending on your maturity in working with agents, you need to take more or less care about optimization. If you only send off 10 agents a day, you work synchronously, you treat AI as an assistant rather than an autonomous part of your team, optimizations will have less impact. But if you only spend $20 a month on a few tokens, saving 50% through every optimization in this deck will only get you to $10. So it's probably not worth a huge effort, right? But compare that to what we might call an AI engineer, an orchestrator of multiple asynchronous agents, dozens, hundreds of agents out there running. Every percent of token usage you can shave off, and every percent of quality you can add is effort well spent across the accumulation of those agents. So, you want to be able to, to do it across, when you got hundreds or thousands of agents and you're running it, kind of as a normal, as a normal AI engineer would. And so the optimizations that follow are ordered by lever and by the effect they have. So if you're on the left side of the maturity spectrum, the first few are more relevant than the later ones. So I'm also going to share some power user tips at the end here. So don't worry, we got some interesting pieces coming up. So level one. So the two biggest levers for optimizing quality of tokens. Level one is the model choice. Common patterns, equal cheap models. Everyone defaults to, if you went into a room of 100 engineers and asked them what was their favorite model today, it would be Claude Opus 4.6, probably, like 99 out of the 100 people. But that's not necessarily what you need to do for, say, a documentation task or something along those lines. They'll excel at that, but you could potentially use, an older, cheaper model that would, fit that much better at a considerable cost savings. So that waste is, the waste there can be significant if you're using, Opus or GPT-5.5 for simple, questions and things that can get out of hand pretty quickly. But if you start to think about it in different ways, you can bring that gap down. And so the cost gap, there's a 24x difference between Claude Opus 4.7 and GPT-5.4 Mini. So model choice impacts both token cost and the quality. So the bigger doesn't always mean better. So that's what I always say. So when you want to use reasoning models, so like Claude Opus and such, planning and architecture, debugging complex bugs, synchronous work where you're driving the agent, and tasks that require large context windows, so like mini files and such. When you use smaller models, you can use that for implementation after planning is done. The reasoning happened in the planning phase. Now you just need the execution. So the execution can be handled by a lesser model, lesser cost impacting model. Quality impact, using reasoning models for implementation can actually hurt the quality. If you have a tight spec, a reasoning model might reopen the plan and second guess it and go rogue. So actually, it might come out and say, actually, this is wrong. I'm going to do it a different way. So, you may want to use a less reasoning type model for implementation. And then the solution. So starting actually in June, I think actually in VS Code as of like last week, there is auto mode, which is before it was based off of choose the best model based off of the availability and the response time that it would give you. Now it's task aware. It's able to assign the right model based on the task that you're trying to do. It looks at what your context was and sends that and makes a choice as to where it's going to go. And you get a 10% discount on that, by a 10% token cost discount. So that can end up being really significant. We've seen data that shows that that context that people are happy with the results that they're getting from the auto mode. So it's auto model switching mode. So it's something that has been very well received. So the lever 2 that we have is to provide only the relevant context. So don't stuff the prompt with, I might need this information, or I might need that. Let the agent discover what it needs, and it can find files and things on its own. So you don't want to attach the entire project. You don't want to say, add the whole entire code base, for a small change. You might, in some situations, I could see some specific situations where you'd need, to stuff it all, a million lines of context into the model, but generally you're not going to need to. And so context engineering is the core skill to build here. All of the following tips are context engineering techniques. So you want to have compacting, which can reduce tokens, but it also comes with some information loss. So that lost information, if it was relevant, you create agent misses and token savings become quality loss. So you want to be very careful with compacting. Use the /clear command. So that would clear out your cache or your context pretty liberally. You want to make sure that you want to start fresh for each new task, or when the window gets too long, And don't try to steer a bloated session with, around 80% of your context filled. Recency bias, it's just not going to let you succeed. So it's something that you want to make sure that you're up to speed on and have all the latest and it's cleared out as much as possible. Tokens don't accumulate across sessions, so throw away context without hesitation. So, your prompt is kind of the always-on context. Don't optimize prompts for fewer tokens. You want to optimize to steer the agent correctly from the beginning. And so prompts, systems, and tools are always in the context window at the beginning, giving them outsized influence. So remember, kind of the lost in the middle bias from earlier. We want to be precise. If you go in and say, fix the bug, okay, that's, it's maybe not going to get you where you need to be. But if you say, issue number 45 describes a bug where XY happens, fix it. That's going to give you that context. It's only a couple tokens more, but you're not going to have those potential misses. If you say fix the bug, it could just go find a bug, a different bug, or something else that you weren't. Now you have to come back and do it. So once the bug is fixed and the tests pass, stop. So this prevents the agent from continuing with like unnecessary work, doing all the git, commit, push, linking files, etc. And so you want to add known context. So if you know where files or other context lies, don't let the agent find it. Provide it. You give it that context. The same is true for documentation, documenting websites and such, where that you want the agent to fetch or the skills to invoke. Whatever you can put there from the start will improve the experience and reduce the cycles and tokens that are used for the same outcome. Especially, if you know it's going to be a long, drawn-out session where you're going to be talking with Copilot consistently. You want to have the right, the right amount of tokens and such, or the right context in place in the beginning, so that you can be as precise as possible. Give it exactly what you need, but not anything more. And so, you want to work in phases. So you want to have the research, and then you want to move to planning, and then you implement. And that is big for a couple of reasons. But so research, it's an optional thing. You can use /research in Copilot CLI. It loads a ton of files. They're not going to be relevant for implementation, but if you do all of this phase in one session, you can carry you'll carry the irrelevant context through all turns, and it'll degrade the quality and waste tokens, even some of the cached ones. And so a better approach here is that you create new context windows between phases. Some duplication will happen, but improved quality will be part of it, and you'll have more token efficiency. So for planning, you want to use good models. It doesn't always need to be Opus 4.7, like I said. You just want to use something with the reasoning capability. I like to look at the when you're talking with a model, it's kind of a relationship, right? You've got to create the relationship where the questions that you ask it are going to drive what it responds with. And so building that relationship and understanding what makes it tick is going to help you get better implementation. It may not be Opus 4.7 or it may be GPT 5.5, and just because it's right for you doesn't mean it's right for everybody else in the room too. So it's just the way these things work. You get along with somebody better than some people better than others. You're going to get along with some models better than others as well. They have a little bit of a personality, and you have to have a relationship with them. And so planning mode is the next step, right? So you want to use that for complex features. For sophisticated features, use plan mode with reasoning models. They excel at viewing plans from every angle and identifying gaps. So the goal is to create a precise specification, a detailed to-do list that covers all the thinking up front and gives the implementation section no room for variance. So you want to, with a clear spec, you can deploy multiple agents in parallel, right? So you have, you'll split it by your architecture layer. You want to define contracts between components, and each agent will work efficiently with only the relevant context. So this approach saves time and tokens, and agents aren't carrying unnecessary knowledge, for their specific task. So let's see this one. Okay, we're doing pretty good on time. So while not strictly context optimization, deterministic controls, like tests, are essential context as well. So they're context engineering tools that can counter non-deterministic LLM behavior. And so what this means is, you want to write tests, have tests, test tests, and even more tests. So the Copilot team, the CLI team, ships about 500 PRs a week. Their number one context engineering practice is tests. 50% of their code base is just tests. Why? Because a test is deterministic control. It either fails or it doesn't. There's no wiggle room in it. And so the agent will execute this deterministic control, and it counters the compounding error problems heavily. If after 10 steps you've landed at 50% accuracy, the test will fail and bring the agent back on track to 99%. You basically restart the accuracy by having tests. So, if you go beyond tests, it's not just tests, of course. So you want to have linters, security scanners, and any other guardrails that you can architect through code. So whatever deterministic controls you can throw at the agent and have it execute, that's a good way to do this. Visualizing it on the context window is another big aspect of it. So here's what we see with a unit test. So there's a buggy change. A failing test tells the agent to stop, you can't continue. The agent corrects the change and then builds on top of it, on top of a stable building, a working base. So it continues making the rest of the changes until all tests succeed and the agent is done. If you don't have tests, the agent will build a buggy change on top of a buggy change, on top of a buggy change, and then it might be done quicker, earlier with fewer tokens. But what you have without it is an incident, and so or a bug, and those costs add up rather quickly. They can be wasted CI/CD minutes, Copilot review cycles, and agent runs spent unnecessarily, human time required to fix the bugs, a debugging session that fills the next context window, etc. So the accumulation of tokens is then much higher, and the cost is much higher than if you'd have just had the test in the first place. So if you spend some time on testing, shifting left, that's what we've done in this industry for the past 15 years to improve our outputs and improve the value. And it's so much more true for agents than it was before. So agent configs, let's examine these agent configs. When we talk about context engineering, often it's basically a one-on-one with agent configurations. So agent configurations are all those markdown files and controls that you can put in places that agents will take into account automatically. So there's persistent instructions, that's your Copilot instructions.md. You have custom agents, that's your the agent MD. You have skills, MCP servers, subagents, scoped instructions, prompt files, and Copilot memory. So we'll look at some of these in more detail and how you can use them to improve quality and tokens. The first one is this your Copilot instructions or your agent MD. These are always on agent guidance. They are, in a lot of cases, I've seen some really huge ones. These are put out everything in every context, whether it's every every time you run your prompt, this is these instructions are put out there, and so they're there for every agent session and every interaction. So the requirement here is that you want to keep them very small. They must be concise. They must be small. They must have you don't want to use AI to generate them. Don't put entire documentation or human readable guides, because that's not who your target audience is. Think of it as it's kind of your human in the loop proactive guidance for every agent. What belongs in them? Your non-negotiables, the log, the agent. So you want to have your non-negotiables, which are like project guardrails that every agent must follow. You want to have agent misprevention, so correct recurring errors, using the wrong testing framework, wrong build command, etc., so that it can avoid those kind of things. And then some statements for output trimming. Be concise, drop the niceties, only return code. Output tokens are the most expensive, so trimming them matters. So you don't want to have it say please and thank you. I think was Sam Altman said they were losing millions of dollars because people were too polite, right? So same goes for what you want to have come back from your model. So research shows that be concise yields almost the same results as the 50-line caveman skill does. Just so everybody knows. So again, the best practices there: don't use AI to generate instructions. It's your chance to kind of guide the agents. You can if you need to, but you want it. AI generated instructions can be very speaky, and they're often pretty imprecise. So you want to write them yourself based on base it on real agent behavior in your project and iterate upon them. So it doesn't need to be perfect from the start. You're not going to get it perfect from the start, and that is going to change over time anyway. So it may become longer or shorter based on what you're going to do. Add those corrections as you observe agent misses, fix things, and make it even more precise. Recreate them. So what also helps is recreating them often. The models and your project change constantly, and so the CLI team throws away their entire instructions every 3 months because they might be outdated. And so they're no longer relevant. They may have no longer contain the required information, or they compound useless information. So it's kind of a living, breathing document that you want to keep as fresh as possible. Custom agents are a way to force an agent into a certain role or way of working. They are best considered as something manually invoked by you as the human. When you want to orchestrate an agent workflow and have an agent behave in a very specific way. So in the example that we have on the screen here, we have a test-driven development agent. It's a TDD red. And even it's one that is very specifically scoped to only implement red. So failing tests. This is something an agent wouldn't do on its own. It would require a lot of prompting. So a custom agent is a nice way to write that prompt out once and reuse it again and again. So how they work, you invoke them manually. They can be invoked automatically, but let's leave that out for now. For our mentor model, you invoke them with a slash command. So in this case, you might say, hey, add an API endpoint and implement the test first, or the harness, or implement the test first. The harness will retrieve that custom agent file and then adjust the available tools accordingly. So that's another neat thing you can do with custom agents. You can adjust which tools the agent has access to. So this itself will also reduce a little bit of the token consumption, though it's not the most relevant lever. So input tokens will get cached, and even though tools can make up a large portion of the system and tools prompt, they're usually not a big lever when we talk about token optimization and such. The real benefit is preventing the wrong paths. So what it will do is prevent your agent from going down a path that you don't intend in the first place. So for example, if you only want it to read an issue in GitHub for getting the specification, not write or update it, you prevent the agent from going down that path by simply not giving it the tool. So skills, very close to custom agents, not quite the same, they're skills. Skills also show you, also allow you to have markdown or a markdown description that makes your agents behave in a very specific way. The difference is a skill is something you offer to your agent based on the task it's doing, and it can be loaded dynamically. So it's not always on context. It's not always part of it. Part of it is, the harness pulls the skill description and puts it into the context window. Same as with tools, but the harness is now offering skills to the LLM. One of the skills, some of the lazy coded context is so when the LLM detects a task matching a skill, for example, work on the API, it tells the harness to load that skill. That's a great way to offload context that isn't always relevant. So something to keep in mind as we're running through there. So you can see that's like an API endpoint session or API skill over here that we have. Best practices for skills, some of the things that we want to do here is don't overdo it. You don't need hundreds of them. You don't need hundreds of thousands of skills. You need enough, the right amount. Don't overdo it. Sometimes, in some cases, a little less is more. Be wary of redundant skills. Really, does the LLM need a React skill when it's already proficient in React? I don't know. So you want to make sure that what you're doing makes sense and is not overly redundant. And you want to only use skills for capabilities the agent wouldn't otherwise have. So like the React thing. You want to maintain them. So as LLMs evolve, some skills become unnecessary. So if you built something 4 years ago, which you probably didn't, but a If you built something if a year ago or 2 years ago or 4 years ago, whatever the story is, it may be irrelevant today because of the advancements in LLMs. It's perfectly fine. Toss it. And let's go. You don't become married to any of these pieces. You're going to have to scrap them constantly. AI is moving so fast that there's always always having to throw stuff out to the garbage pile. So now we're going to move on to integrating with third-party tooling. MCPs, the Model Context Protocol. They add external API calls and dynamic tools to your agents. And so once they're activated, they return tool descriptions that go into the context window. So GitHub MCP offers a Git issue tool. So users can say read issue number 45, and so the LLM will recognize the tool and it'll invoke it via the harness. You want to be rigorous with MCPs and make sure that you understand they can bloat tool descriptions, which is a lot of token waste. They can, more importantly, they can lead agents to call undesired tools, and they can, you want to deactivate MCPs that you don't need or put them into custom agents and such. For example, an example of an MCP is the Playwright MCP. It's powerful for web front-end work. It can autocorrect and view websites automatically. However, it's costly. Screenshots, page reads consume many tokens. If always on, it might trigger unnecessary work, and like reading a web page for a simple CSS color change. Use it. The better idea is to use it only in combination with custom agents when it's actually needed. Okay, we're doing pretty good still. I hope everybody's still awake. So the next one is offloading task-specific context, the subagents. Subagents open a second context window for specific tasks, like research or some of those, preventing the main session from filling with irrelevant information. The subagent processes documents, creates a summary, and returns only relevant information to the main session. This improves main session quality, but comes with the trade-off of tokens spent in the subagent. So, when you want to use subagents is, if the agent often decides automatically to do it, or you can explicitly invoke them for research tasks. So you want to use cautiously. They're kind of a conditional optimization. It's something that when you need to use them, they're great to use, but you don't want to use them always. What else? So these other agent configs have less impact on tokens and quality, which is kind of, they're still good to be aware of. You want to have, scoped instructions, right? They're useful for monoliths and with distinct code sections, but very conditional. You have to meet certain conditions to where you want to use scoped instructions. You'll start with static instructions and only move to scoped instructions if they become too long. Prompt files, reusable prompts manually invoked. They're not supported in Copilot CLI, but usually skills or custom agents are better choices than prompt files these days. Kind of goes to what I think about throwing it to the trash pile. I think prompt files are kind of starting to be on the way out as they move towards skills or custom agents. And then Copilot memory, it automatically learns from your behavior and team patterns, creating instructions that improve agent quality over time. So it works in the background. It's it's not much that you can proactively optimize anyway, but it's could be worth checking periodically. So we just got a few more slides, and then we're done for this section. So some power user guidance that we wanted to throw in here. These require more knowledge and testing. They sometimes trade quality for token savings, but these are some things that you want to do. Think and code. So you want to create scripts to filter outputs before analysis. For example, filtering the GitHub REST API to relevant fields only, or use CLIs versus. Or the next thing you want to do is use CLIs versus MCPs. So CLI tools are a little more optimal. They can debate ongoing CLI tools like GH are already known to models and maybe leaner than their MCP equivalents. Shell output optimization, so tools like RTK, trim, CLI output, tools like RTK can trim CLI output to agent relevant information only. There's the Chronicle tool as well. You want to use the /Chronicle tip. It analyzes your Copilot CLI session logs to suggest prompt optimization, something that you'll want to use considerably throughout. And then collapsing tool calls. You want to batch multiple tool calls into one to reduce some of the turns. The last one is model-specific context optimization. So this would be only for power users for the most part, but you would only with power users with thousands of agents, not recommended due to kind of the rapid model changes, but it is something that power users can get into and start thinking about. Important future traits. So we're going to end this session with a more forward-looking, long-term outlook on what things to focus on to be truly successful with agentic development. So one, you want to build your analytical skills. What sets developers apart was never just writing the code. It was the analytical skills, building domain knowledge quickly, understanding customer needs, and translating requirements to technology. This is your strong suit as a developer. This is what you should be really good at. It's highly demanded going forward. Agents can't do this. They don't have this capability yet. So they won't understand customers or make high-level decisions about what matters in their application. They'll execute, but not strategize. So the second thing that we always say is to apply good architecture. It's more important than ever is good architecture. It reduces agent misses, provides navigation guardrails. It'll prevent agents from placing code in the wrong locations, and it helps maintain code quality. So some of the recommended approaches are domain-driven design, hexagonal architecture, CQRS, and event-driven design. These architectures clearly distinguish low-level technology like REST APIs from the differentiating domain core, giving agents excellent guardrails. And so debates about 5-line functions, comments, or semicolons are no longer relevant. Architecture is what matters here. And then lastly on that part, we want to iterate on prompts and agent configs. So you're now a context engineer. This isn't one-time work. It's not something, it's not set it and forget it and go on. It's continuous engineering. You have to consider this all the time and take it into it and make this as good as possible because it can go off the rails fast. You approach it with an engineering mindset. Set agents up for success consistently. Tools like the Chronicle and they can help analyze and optimize your prompting over time. So that's something that you want to continue to sharpen your skill, but also sharpen the skills inside of your agents and such. And so we're going to wrap up. I understand this is a lot of information to take in. So as a reminder, here's the 5 biggest tips that we can give you to improve your agent quality and token spend today. They don't, hopefully don't require too much effort on your part. This is just a repetition of what we learned previously. So, you want to choose the right model for the task. You want to provide clear guidance in your prompts. Use split your tasks. Use that research plan and implement. Use it to your advantage to reduce that context size. Provide deterministic guardrails. So you have the tests, the linters, security scans, etc. And maintain a concise human-written Copilot instructions file going forward. So, that'll help you trim the outputs and help you, use it as your agent miss log. So if you take anything out of this talk, it's, write as little context as required and as much as necessary. That's the biggest line, the through line throughout the entire presentation here. Implement those 5 tips and you'll already be in a pretty good place. So then it's just growing and maturing into this new age. And so we'll all be happy, we'll create more value, and we'll avoid spending so many tokens on some of the useless gambles. Again, I'm Todd Toller, Microsoft CSA. I'm happy to have you guys here. We appreciate your time. Thank you so much for being here. Thank you so much for being GitHub and GitHub Copilot users and hopefully Microsoft customers as well. We truly appreciate you and appreciate your time today.